Alright, hello, this is going to be Solidworks CSWA practice problem 4.27. If you want to follow along with the video, make sure to follow the link in the description, which will take you to the official Solidworks practice problem database. So let's get started. First is make sure our units are in MMGS, and we'll start sketching the front plane. So we'll start with a little circle here. And in the front view drawing it says R11, so we're just going to say diameter 22. And before we do anything, let's draw a horizontal center line because we are going to need the mirror tool. The part as a whole is asymmetric, but the right side extrusion, that side is symmetric, so we can use mirror. And also another thing, be careful, those for the arc R44, that is not a concentric circle that's trimmed down. Be very careful of that. That is just an arc. So I'm actually going to draw a vertical center line here too, just to have like a barrier. And I'm just going to draw a horizontal line. I'm going to go ahead and mirror that line to the other side. I'm going to close them out with a vertical line like this. And then I'm going to add another line here. And I'm going to make sure its midpoint is coincident with this horizontal center line. So now it's even. And we're going to start dimensioning. So the distance between origin and this line, right side line, is going to be 35. And then we're going to have an arc. So I'm going to go to arc, click tangent arc, because it should be tangent with this horizontal, and then it connects with this point. And the arc's actually not tangent with this line. It's only tangent with this line. So I'm going to go ahead and mirror this to the other side. And then I'm going to make sure that the arc's radius is 44. Like so. And let's make this a little bit thinner. But we're going to fully define this part a little later, and I'll show you when. So for now, we're going to need a point. And what's the purpose of this point? It's to establish the R127 arc, which is going to serve as the outline for our slot on the left side. So we're going to dimension the distance from this point to origin. Its vertical distance is going to be 18. And then its horizontal distance is going to be 12. 12 and 18. So now that point is fixed. So now we can draw two center lines. The first center line is going to be horizontal, like this. And the second center line is going to be diagonal, but we're not going to define it yet. And then, like I said before, the arc, we're going to use a center point arc. So I'm going to select the point as a center point. I'm just going to draw an arbitrary arc like this. And now I'll dimension the arc as being 127. So now you have two intersections, and we'll use those two intersections to build our slot. So first of all, I'm going to make this arc that we just created, and that's construction because we're not actually using it. And then we're going to click arc, and then we're going to click center point arc slot. So our first point will be the center point, which is going to be here. And then I'm going to select the intersection and then the next intersection, like this. And then we're going to create our arc. And now I'm going to offset this arc by a distance of 7. And then I'm going to dimension the arc from the offset slot as being 23. And I'm going to have a horizontal line like so. And I'm going to make sure that this horizontal line is tangent with the outer slot, and its endpoint coincident with this arc. Now for this bottom part, I'm going to draw a horizontal line, a diagonal line, and I'm going to make it tangent. Oh, actually, hold on. Let me delete that. Going to make a diagonal line, and let's make this point coincident with the arc. Let's actually add a tangent relation as well. Tangent relation. And then we're going to focus on this corner point right here. So the horizontal distance from this corner point to the origin is going to be 52. And then the angle between this diagonal and this horizontal construction line we created earlier is going to be 45 degrees. And notice that when I establish the angle of this line, this center line, diagonal center line we created earlier, that we never defined, it followed as well. And the only reason this follows is because of this tangent relation at the bottom. And then I'm going to add a slot, or a fillet, an R12 fillet to that corner we were just working on. So this corner, so R12 fillet. Select OK. And then finally, if you look at the top view from the engineering drawing, you'll see that the distance between these two lines for the right side extrusion is going to be a total of 67. So now everything is fully defined. But we're not done. We obviously still have the middle cut to do. So I think one thing to notice is the dimension where it says 17 typical. So what does this mean, typical? It means that the dimension is going to appear more than once. So if you look at it kind of looks like a, what do you call that? In like during Halloween, there's this candy that looks kind of like a traffic cone. I forget what it's called. Actually, let me search it out real quick. Let's see. Halloween candy traffic cone. Oh, candy corn. That's what it's called. Yes, candy corn. So that candy corn shape, its distance from this diagonal and the distance from this horizontal is the same, 17. So I think we're going to have to use offset entities. So I'm going to use offset entities. I'm going to click this line, and I'm going to reverse the offset to make sure the distance is 17. We'll select OK. And I'm going to do the same thing for the opposite side. So offset this diagonal line. Well, I kind of only want the diagonal. Let me see, offsets. I guess we'll just keep it. So we're going to keep it like that. Actually, you know what? I'd rather not use offset. I'd rather just delete this. And I'd rather just create a parallel line. So I'm going to create a horizontal line like this. And I'm going to create another line, a diagonal line like this. I'm going to make sure this diagonal line is parallel with this one. So parallel. And let's make their distances between the edges be 17. And I'll follow with the other side as well, 17. 17. And then I'm going to connect these two endpoints of the lines with a arc. It's going to be a tangent arc, I believe. Well, it's going to be tangent with both lines, so I'm going to make a tangent arc connecting both lines. But then I'm going to make it tangent to the other line, and then I'm going to add a radius of, it says 25 to it. And then finally, we're going to add some more tangent arcs that are going to be coincident with the slots. I'm going to add it on the other side as well, coincident with the slots. And let's make sure those arcs are tangent with the edge of the slots. Tangent. And tangent. So now you got your candy corn cut. And these two arcs are equal, so I'm going to give the equal constraint. And I'm going to just dimension one of them. So this arc right here, bottom corner, is going to be R11. So now you have your fully defined candy corn cut. And yeah, everything is defined. I believe that's it. Yes, that is it. Okay, so it looks very messy, but it is fully defined. So we can start our extrusions. So I'm going to features, extrude boss base, and I'm going to, there's 3 different extrusion depths. I believe everything is going to be mid-plane extruded. So let's change it from blind to mid-plane. And then let's do 18. And I'm I'm going to select contours, and I'll select this contour and this contour. So those will be 18 to start. So we'll select OK, and then we'll extrude the other end, extrude west base, the same sketch, and then this time we're going to change the value to 30 from 18, and the selected contour will be the slot, like so. So that should be 30, mid-plane extrude. Select OK. And now what we need to do is we need to create a cut for the right side extrusion, and it will be a cut of depth 7 from the top plane. So I'm going to click extruded cut, select the same sketch, so we're going to do a blind extrusion of depth 7, and it's not going to be from the sketch plane, it's going to be from a surface, and that surface will be this front surface, and the selected contour will be the right side. So it should cut 7 deep from the top surface, and we will select OK, and that should be your full completed part. So I'm gonna check the answer, evaluate mass properties. For my volume, I ended up getting 181,858 cubic millimeters for my volume. Say that again. 181,858 cubic millimeters. So I hope you learned something from this video, and I'll see you in the next one.